Okay, so it's chapter 3. We're still talking about linear equations, but now we're adding this new word functions to your vocabulary. So like, what is a function? Really, a linear function is no different from a linear equation. Equation just means there's an equal sign in it, and functions is a big vocabulary word that you're going to start learning about now, and you'll continue learning on until you're like in pre-calculus, right? So there's two types of, let's call them expressions or things you can graph. One is a relation and one is a function. So we're going to be talking about the differences between those today, and you're also going to be learning about what domain and range mean. All right, so we're going to start with this table. We're going to graph it. So I have already graphed it in Desmos. Where I thought I graphed it in Desmos. Where are my green dots? There they are. Okay, so here's the table, right? 1, 2, 3, 4, 5. And then at point 1, the y value is 11. At x equals 2, the y is 12. And then for these other three x's, y equals 13. So this is a table. That means it's a collection of points. This isn't actually connected by a line or a curve, right? Because they're just telling us this table of points. So what we have right now are 5 data points, right? And this is what they look like. So let's come back. Let's talk about it a little bit. What we're going to talk about is, first, is this a relation or a function? And then we're going to talk about the domain and range, okay? So if we look at these definitions, which you should pause the video and write them down right now. Miss Aisha can pause for us. A relation is a set of ordered pairs. So this is a set of ordered pairs, right? Because that's all it is. There's no curve or line connecting the points. So what we've just graphed is a relation. But is it a function? So this is where we have to check, well, it could be a function too. A function is when each x value or each input has only one output. So that means when I look at x equals 1, what is it allowed to be? Well, it's only allowed to be 11. So that's okay. So it only can have one output. So when x equals 2, it's only allowed to be 12. That's okay. And when x equals 3, it's only allowed to be 13. So yes, it actually is a function because for each x value, there's only one y value. It wouldn't be a function if, for example, you came over here and it said, oh, when x equals 1, y is allowed to be 11, 12, or 5. Now this x value has 3 possible y values, so then it would not be a function. But if for every one x value you only have one output, then it's a function, right? So this table is a relation and it's a function. So now let's talk about these last two, domain and range. So domain is the list of all possible x values that the function or relation is allowed to be. So if I look at this, let me my text box. What are the possible x values for this function? Well, according to this table, it's allowed to be x equals 1, 2, 3, 4, or 5. That's it. It's only allowed to be those 5 numbers. And I can't write x equals 1 through 5 because that's not true. That would say that x could be 1.1, 1.2, 1.3, all those numbers, which it can't be. It's only allowed to be these 5 whole numbers. And then the range is the set of all possible y values that are allowed in a function. So in this case, what's our range? Well, y is allowed to be what? Let me make this a little bit bigger for you in case you can't see it. Y is allowed to be, let's see, well, it's all on the table, so that's easy. Y is allowed to be 11, 12, or 13. That's it, right? And so I can pull this from this table, or I can come and look at it in the graph, and that's also true. X is only allowed to be 1, 2, 3, 4, or 5, and y is allowed to be 11, 12, or 13. That's it. That's the domain and range, okay? Domain and range seems tricky, but it's not. You're just looking at all the possibilities, and it's something you'll keep working with till calculus, talking about domain and range. So let's practice this stuff. Let's keep going down. All right, so we have 2 new tables. So this one, let's start with A. So for each table, first we have to figure out, is it a function? Well, we know they're relations, right? Because relations just means a set of ordered pairs, and these are all ordered pairs, so it's a relation. So what's important is to figure out if it's a function. So if it's a function, for every x value, there's only one y value. Yep. 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 And yep. And the other way you can also notice it, if it's not a relation, it would be like there are two columns with a number 3 in it. So that's meaning when x is 3, you have two different possible numbers. So that's not true here. So like it might be something like this. I'm going to show you how you could see it in a table. It might be like x is 1, x is 2, x is 2. And then you had these different numbers. Because at x equals 2, there's two different possible values, that wouldn't be a function. But that doesn't happen here. So this, well, I'll have my answers for A over here. This is a function. Yes, it's a function, right? Why? Because for each x, there's only one y. What's the domain? Well, the domain are all the values that x is allowed to be. So in this case, x can be what? 2, 3, 4, 5, and 6. Okay, and what about the range? What is y allowed to be? Well, y is allowed to be 0, 1, 2, 3, and 4. Okay, great. Let's try b over here. So now, is b a function? -3, -1, 1, 3, 4. Yeah, there's not a repeat of x values, and for every x value, there's only one y value. So yes, let me use a text box. Yes, this is a function, right? All right, now let's figure out the domain. What's x allowed to be? X is allowed to be -3, -1, 1, 3, and 4. Not so hard, right? And what's the range? What is y allowed to be? It's allowed to be 1, 3, -2, 2, and 6. Okay? So this is how you find the domain and range using tables. Sometimes you're going to have to do it from a graph. So let's talk about that. Instead of it being a set of points, it's going to be a curve or a line. So let's look at this graph. This graph is like an upside down U. It asks, is it a function? So this might be harder to tell without a table, right? Because for it to be a function, for every one x value, there's only one y. Every one x, there's only one y. It looks like it might be true because there's this thing called the vertical line test. So what that means is if I draw a vertical line, right? Let's get a yellow one here. If I draw a vertical line at any point on the graph, maybe I won't make it yellow, it's hard to see. So if I draw a vertical line at any point on the graph, here, here, doesn't matter where, anywhere, at every possible point, if I draw a vertical line, it can only hit the curve once. If it only hits the curve once, it is a function, right? Because that means there's only one output for each input. So we can write here, yes, is a function. Let's take a little note here that the vertical line test, if a vertical line, let's make this smaller so it fits. Let me change this real quick. If a vertical line is drawn through any point on the graph, it can only touch it once. And then the important part here about the vertical line test is that if a relation passes the vertical line test, it is a function. Right? So you might want to get those down in your notebook. So vertical line test, you literally get your pencil and draw a vertical line through the graph. If it only hits the curve at one point, and one point only, it passed the vertical line test, which means it's a function. It means that for every x value, there's only one y. So this one is a function because it passes the vertical line test. So now let's find the domain. The domain is a list of all possible x values. Okay, so I'm looking at these x values, and I can see that this red curve is somewhere between, I think this grid goes by 2, so somewhere between -2 and 8. It's in between there. But these arrows mean this line goes on forever and ever and ever. It doesn't stop. So those arrows mean it continues on forever and ever. And you can see as it's going down, the curve or the bell or the upside down U, whatever you want to call it, it's actually called a parabola. It's getting wider and wider and wider. And it's getting wider and wider and wider for an infinite amount of time, which means eventually it will be as wide as infinity. So x is allowed to be anything. X is allowed to be any number. Or you can say x equals, you can also list it like this. Negative, it's allowed to be any number between negative infinity. I'll write it with a drawing because it will be right. X is allowed to be what? Anything from negative infinity to infinity. That's one way you can write it. You can also say x can be all real numbers, right? Any number on the number line. There's no restrictions on x. It's allowed to be anything. Now let's look at the y. Well, what values are y allowed to be? Well, I notice there's a maximum, or the highest point that this curve hits is right here. Okay, so this is the maximum point, and then it keeps going down forever and ever and ever, right? Because of those red arrows. So what does this mean? This means that y is allowed to be, we use a parentheses to say that it doesn't include that number, right? And why don't we include negative infinity? Because it's not a real number. And it's allowed to be anything up to whatever this number is at this maximum. So if I look at this number, these are by 2's, right? So this is 14. This is halfway between 14 and 16. So this is up to positive 15. And then I use a bracket. Okay. If you use a parentheses, it means it's almost like saying greater than or less than. It's allowed to be anything up to this number. Anything up to but not including that number, right? And then if you use a bracket, so you can either use this bracket or that bracket, depending on which side you're talking about. That means, that means anything up to and including that number. So if you look at this, the reason I used a bracket on 15 is because y is allowed to be 15. This is a point, y equals 15, right? It just can't be anything bigger than that. Where I have a parentheses on negative and positive infinity, because those are not real numbers, and the graph is never actually going to touch infinity because it's not a real number. It's just something that mathematicians use to explain this idea of going on forever and ever. All right, let's try a couple more. So here are our two functions. We just did this one, right? And then here is another one where it's just a number of points. So two more vocabulary words you want to write in your notebook today are continuous and discrete. So continuous means that the domain of a function is continuous, and it includes all the numbers within a given range or value, right? So this is continuous because it's a smooth curve. It includes any number between negative infinity and infinity. Continuous, smooth curve. Where this function on the left, this one's discrete. So you might want to draw these pictures of these functions next to your vocabulary word. This is discrete, right? Because it includes just specific numbers. The domain for this one, if I were to write it, would be what? The domain would be x equals 1, 2, 3, 4, 5, right? And continuing on, I'm not writing them all. It's only including those specific numbers, which is why they're dots. I can't say the domain is 1 through 11 because that's not true. It's only allowed to be these specific numbers. So that's why this is discrete. Discrete, continuous. All right, we're going to do one more example before you practice today, which is we're going to figure out if these are functions. Okay, so A, is this a function? Yes or no? Well, the first thing I'm going to do is come through and check. Do I only have specific x values? So I have 1, 5, 7, and 8. So those don't repeat. And because I don't have any repeating x's, then yes, this is a function. right? Because I don't have any repeating x values to say that there are two outputs for them. All right, what about this? Is this a function? Well, for this one, I can do my vertical line test, and I can see that for any point on this graph, if I draw a vertical line, it only hits the line once. So all lines are functions. This is a linear equation, right? We could write that equation. It is a function. It only hits it once. All lines are functions. Something you can remember. Right, is this a function? Okay, so this is an input-output table. So this is saying if I put in the number 1, I get 17. If I put in the number 2 for x, I'll get y equals 17. If I put x equals 3, I'll get y equals 11, and so forth. So all I really need to check here is that my x's don't repeat, because only when my x's repeat do I need to check if it's a function or not, if it has different outputs. So I can see that my x values don't repeat. 1, 2, 3, 4, 5. So right away, because they don't repeat, I can say, yes, this is a function. Now if I come over here and look at x and y, input and output, I have -2, 3, and 4. So they don't repeat, right? But what I'm noticing that is making me a little worried is that this one has 2 arrows from it. So what this means is that if I have x equals 3, if x is 3, y is allowed to be 6 or 7. Because there's 2 possible outputs there, this is not a function. And I want to show you why. -2, 3, 4. I'm just going to come over here and graph it in Desmos. So we've got -2, 3, 3, and 4. And I have to put 3 twice because there's 2 y values for it, right? 5, 6, 7, 8. 5, 6, 7, 8. So if you come and look at this graph of these points, right, that I put here, it's not a function because if I were to draw or perform the vertical line test, do you see that when I get right here at x equals 3, which I can type so you can see, that it hits the set of points more than one. It's hit it here, it hits it there. So it doesn't pass the vertical line test, which is why it's not a function. So you can come back here and say, no, it's not a function. And you can do that from here, or if it makes more sense for you to plot it and graph it first and use the vertical line test to check, you can always do that. All right, so that is the first topic for 3.1. We've learned, is this thing a function? And then how do I find the domain and range? Okay, I'll see you next time.